Ever wonder how your smart speaker or an AI in a video game or even a recommendation engine actually thinks? It's not some kind of magic. It's actually a special kind of language we teach them, a language built on pure logic. Today, we're going to pull back that curtain and see exactly how machines learn to reason.
So really, what is happening inside that digital mind when an AI figures something out? It's doing way more than just matching keywords. It's actually using a powerful process called inference. This is how it connects the dots and draws new conclusions from stuff it already knows. Let's dive in and see how that works.
All right, here's our game plan. We're going to start with a big idea, logical inference. Then we'll look at a simple foundational logic before leveling up to the really powerful stuff, first-order logic. We'll break down how it works, and most importantly, why it is an absolute cornerstone of modern AI.
Okay, first up, what is logical inference? I want you to think of this as the engine that drives all AI reasoning. Seriously, it's the core process that allows a machine to think.
So, at its heart, inference is just the process of figuring out new things from what you already know. It's all about reading between the lines. An AI that can use inference doesn't just know what you tell it directly, it can figure out what's implied. And that ability lets it go way beyond its initial programming.
And this one process, it is the key to pretty much everything we consider smart in AI. It's what lets a machine truly comprehend things, figure out context, and even make predictions about the future. Without inference, an AI is basically just a fancy database. With it, it becomes a genuine problem solver.
But to do this kind of heavy lifting, an AI needs a language, a really formal, structured way to make sense of the world. So, to get the hang of it, we're going to start with a pretty basic one.
Our first stop is what's called propositional logic. Now, this is a foundational system, and it's fantastic for reasoning about very specific, very concrete situations.
This type of logic is all about simple statements and the relationships between things. Think about words like on, under, before, or after. It's all about connecting specific objects and ideas in a really direct, no-nonsense way.
For example, take the sentence, "The cat is on the mat." Propositional logic gets this perfectly. It understands that spatial relationship. It knows where the cat is in relation to the mat. It's simple, it's direct, and it's really useful for these kinds of specific facts.
But let's be honest, the real world is rarely that simple, right? We need to reason about general rules, not just about one cat, but maybe about all cats. To handle these big, abstract ideas and entire categories, AI needs a serious upgrade.
And that upgrade, that next level, is first-order logic. This is where AI reasoning gets truly powerful. This is what lets it understand and work with general principles about how the entire world works.
So here's the key difference. Propositional logic is tied to specific sentences, right? The cat is on the mat. First-order logic is a much more powerful formal system. It uses variables and abstract rules so it can reason about general ideas. Not just one cat on one mat, but the very concept of anything being on any other thing. So how does this souped-up logic actually work? Let's pop the hood and break it down with the most classic example in all of philosophy, just to see how facts and rules come together to create brand new knowledge.
First, we got to look at the building blocks, the grammar of this language. We've got variables, like x, which can stand in for any object. We've got quantifiers, which let us say things like for all, or there exists at least one. And we have predicates, which are like questions that can be true or false, like is x a human? These are the parts we use to build our knowledge base, to represent both the specific facts we know and the general rules that govern them.
And here is where it all clicks. An AI is given a general rule for anything x. If x is a human, then x is mortal. Then it's given a specific fact, Socrates is a human. The AI's inference engine takes that general rule, applies it to that specific fact, and deduces something totally new it was never explicitly told. Therefore, Socrates must be mortal. That right there is the essence of knowledge representation and reasoning in action.
Okay, so that's a cool logic puzzle. But why does any of this matter? Why is mastering this kind of framework so absolutely critical for building the AI that's shaping our world? Well, it really all comes down to this. First-order logic gives AI a solid, structured blueprint for thinking. It's a reliable system for an AI to represent facts, to encode rules about the world, and then to actually use that knowledge to draw its own logical conclusions. And that blueprint,
That's the foundation for building what we call truly intelligent agents. We're not just talking about processing data anymore. This is about building AIs that can actually understand their environment, make intelligent plans, and go out and solve complex, messy, real-world problems.
Which leaves us with a pretty fascinating final thought. We've seen the logical engine for how a machine can reason. So the question really isn't if a machine can think logically anymore. The question is, how far can that structured thinking actually take it? If we can teach a machine to reason from facts and rules, what are the true limits to its intelligence?